Good morning, this is Mr. Shields back again with another video. Today we're going to be graphing linear inequalities. This is an old topic that we covered before, but I wanted to review this topic here for lesson 9 because lesson 10 is actually going to be dealing with solving linear inequalities here, or systems of equations with linear equalities, I should say. So diving right into the topic here, what is a linear inequality? Well, it's similar to linear equations. So for instance, x plus 5 equals 10 or something like that. But instead of having the equal sign in the middle, you're going to have that inequality symbol. So for instance, you might have greater than or less than, or you could have greater than or equal to or less than or equal to here. And then for solutions, the second part that I've listed up here, all of the ordered pairs that make the inequality true. And so we will see in our very first sample problem a list of inequalities, and we can look and determine whether or not those are true for that particular equation. So we'll discuss what that means in a second here. If you don't already have a copy of this paper here, I would recommend printing it out. If you don't have a printer or anything like that, no worries. You can just obviously handwrite the notes here. So let's dive right into this topic here. So if I take a look at graphing inequalities, the steps are listed for you here. First, you're going to want to put the inequality in slope-intercept form. And this should seem familiar to you. We've done this quite a bit here. Y equals mx plus b form. We obviously won't have the equal sign here because we're dealing with inequalities. Step 2 and 3 are very, very important. So make sure you have this written down. You're going to want to reference that. Especially when we look into some examples here on the next page. So if I take a look at step 2, it says use a solid line when I have less than or equal to or greater than or equal to symbols here. So if I have a line under this sign, it's going to be a solid line. Conversely though, it's going to be a dotted or a dashed line if I have just a less than symbol or greater than symbol here. All right, so in addition here, the second part of our graph of these linear inequalities, I'm going to shade above if I have a greater than sign or greater than or equal to sign. And then conversely, we'll shade below if it's less than or equal to. So let's take a look at our very first example that's listed up here. 2x minus 3y is less than 15. Well, one thing that we have to do beforehand is we have to get it in that slope-intercept form. And unfortunately, it's not already done for that. What does that really mean? It just means we have to solve for y here. So let's go ahead and do something that we've done quite a bit in the past here in previous classes. So I'm going to try to get that y by itself. So the first thing I have to do is move the 2x over here. So I'm going to go ahead and subtract 2x. And then I'm going to be left with negative 3y is less than negative 2x plus 15. Okay, so then my final step here is I'm going to get the y by itself. I need to divide by that negative 3. Now, hopefully you guys remember when I divide by a negative, I have to change that sign here. I got to flip it here. So that less than sign is going to become a greater than sign. So we'll have y is greater than equal to negative 2 divided by negative 3. That just becomes a positive 2/3 x. And then, of course, 15 divided by negative 3 is going to give me a negative 5. So that's my inequality. And I can use that in order to make my graph. So what do I know from this sign right here? Well, it's a greater than sign. And that greater than sign tells me I'm going to be shading above. But the greater than sign also tells me it's going to be a dotted line here as well. So when I go ahead and graph that, I have to start with my m and my b again in order to make my graph. And so my b here is a negative 5. And my m, which is the slope, is going to be 2/3. And then I can begin my graph. I always begin with my b when I'm graphing. So I'm going to go down to negative 5, 1, 2, 3, 4, 5, put my dot here. That positive 2 tells me I have to go up. The positive 3 tells me I go to the right here. So I'm going to go up 2/3. And those are really the only 2 points I have to graph here in order to do this particular graph here. And so we've already mentioned that it's going to be dotted here. So I'm going to go ahead with my ruler here and make a dotted line, and hopefully we'll be fine here with this dotted line. Now, I've made my dotted line here, so I'm going to go ahead and put my little arrows on the end to make it look okay. And then once I've done that, I have to go ahead and draw my shade. And in this case, we're going to be shading up. And you can, use a lot of ink if you want to, but I'm just kind of shading up in general here. Now, let's go back to certain points once we've got our graph here. Because if you'll remember some of these points here that we had up top. So 2 and 5 here. So 2 and 5. So if I go to my graph and go 2 and then go up here 5, and move it up so you can see that here. Is that a solution to the equation 2, 5? Yes, because it's in the shade. So if it's in the shade, then that would be a yes. Move it on down here so you guys can actually see it. What about the point -1, -7? Well, if I go ahead and graph -1, -7, I'm actually going to be underneath the line here. So in that case, I would that would be a no, because it's not going to be in the shade. All right. Move it up here. Sorry about that. 2 more points. We have 3, -4. So let's go down here. We got 3, -4. So that's not in the shade. So nope for that one. Slide that back up here. And then finally 0, 0, the origin. And so if I were to graph that, you would see that's in the shade. So if it's in the shade, that's a yes. So let's slide it up and we'll put a yes here. Okay. So let's go to our next page, and we're going to probably be referencing that previous chart here on the front with step 2 and step 3. So if you don't have it handy, I suggest you get it handy, because you are going to need that as we go along here. All right. If I take a look here at number 1, I'd actually already set this one up here for us in the interest of time to make sure that we can get through these pretty quickly here in the time that we have. So if I look at number 1, it's already in slope-intercept form here. So I've got the y is greater than 1/3 x minus 5. And so I identified my y-intercept, which was -5, and I identified my slope, which was 1/3. And so if I go down here, I plotted my -5 here, and then for my slope, I went up 1/3, up 1/3, and then I also went in the opposite direction. Now, because I had a greater than symbol here, I had a dotted line here. And so I drew that dotted or dashed line here. And since it was a greater than symbol, I shaded upward here. Okay, so that's example number 1. Let's try to do a few more examples here. So let's take a look at number 3 here. So number 3 is kind of like the example we had on the previous page where we had the 5x, where we have 5x minus 2y is greater than 12. First thing I need to do is solve for y. So I'm going to subtract that 5x, and then I'm going to have a -2y greater than -5x plus 12. Then I'm going to go ahead and divide by a -2 here. Okay. Now, when I divide by -2, danger, danger, I got to flip my sign here because I divided by a negative number. So now I'm going to have y is less than. What I get when I do -5 divided by -2, I'm going to have a positive 5/2x. And then finally, 12 divided by -2, that's going to give me a -6. Now, once I have that information, I can go ahead and start graphing here because I can identify my slope and my y-intercept rather easily here. My y-intercept is going to be that -6, and my slope is going to be that positive 5/2 here. Okay, so now I'm looking at this symbol here, that less than symbol, which is going to tell me what direction my graph is going to go. First things first, let's plot. So we have the b is -6. So 1, 2, 3, 4, 5, 6. So here's my dot here. And then I have a positive 5, which tells me I have to go up. And then the positive 2 tells me I have to go to the right. So I'm going to go up 5 over 2. 1, 2, 3, 4, 5. And then over 2. Same thing here. 1, 2, 3, 4, 5 over 2. And then 1, 2, 3, 4, 5 over 2 here. And so since it's a less than symbol here, I'm going to go ahead and have a slashed line here. So I'm going to go ahead and slash my line or dash my line, whatever you want to call it. And then I have to determine the direction in which I'm going to throw my shade here. And so since it's less than, if you remember from the first page here, I'm going to be shading downward here. Okay, so very, very, very important that you have that front page here written down here with the steps 1, 2, and 3, because I'm going to be referring to that, but I'm not going to have it up there in front of me. So that's what I'm referring to. Okay, and I'm making that selection. And so what would be a solution here if someone were to ask you? Well, any point in the shade would be a solution. So for instance, if I had positive 5, 0, 1, 2, 3, 4, 5, 5, 0, that would be a solution, okay? Any point that's in that shaded area. But if I had, let's say, negative 2, positive 7, that would be out of the shade, and that would not be a potential solution, okay? So let's take a look at number 5 here. So number 5, we have x minus y is greater than or equal to 8. So first thing I need to do is get y by itself here. So I'm going to go ahead and solve for y. So I'm going to move that positive x by making it a negative, aka subtracting it. And then I'll have a negative y is greater than or equal to negative x plus 8. Now, I can't keep that negative y, so I'm going to have to change that here. So I'm going to divide by a negative 1 here. Danger, danger. Once you divide by negative, you're going to have to flip that sign here. So now I'm going to have a y less than or equal to a positive x minus 8 here, okay? So once we have that equation, we can go ahead and graph it. We just need to identify the slope and the y-intercept. The y-intercept is going to be a negative 8, and the m is just going to be that imaginary 1 over 1 here. Okay, so begin with the b. So I'm going to go down here and graph negative 8. 1, 2, 3, 4, 5, 6, 7, and 8. So there's that graph right there. And then we have to go up 1 over 1. So we're going to have a lot of dots here, as you can probably imagine. So up 1 over 1. So this one's a little easier to graph. It's just there are a lot of points, obviously, to go ahead and do. And don't worry if you don't have graph paper, just do the best you can. I'm really just going to be looking to see whether or not you have a dashed line or a dotted line and what direction the shade is going in. So don't worry about that. So since I'm going to be graphing this inequality, that less than or equal to sign is going to tell me that I'm going to have a solid line here. So let me just go ahead and draw my solid line. And since it's less than or equals to, I'm going to be shading down here. Okay. All right. And so once I have that, I'm pretty much good to go. So what are some potential solutions here for this? If you were given a set of points, for instance, let's say I was given the points, 3 and negative 9. Would that be a potential solution? Well, if I go over 3 and I were to come down to negative 9 somewhere down here, that would be a solution, okay? But if I had 0, 0 right up here, that wouldn't be a solution. Why? Because it's not in the shade, okay? So those are just some potential points here to keep in mind. All right, so let's do a couple more examples here. And hopefully you guys will remember our Hux and Voy, or Hux and Hoy, I believe I should say. So we have the Hoy here. So let's take a look here. I have HOY. So hopefully you remember what the H stands for, that being horizontal. The O is not really an O, it's a 0. And then the Y, or Y equals, or the Y axis here. So how is this going to look different than the previous examples that we have before here? So if I take a look at this one, I have y already by itself, but if you compare it to the previous inequality, I don't have like an x minus or x plus or anything like that. I just have that single -4. So what that's going to tell me to do is I'm going to go ahead and have a special kind of line here, a horizontal line. So I'm going to go to -4. So 1, 2, 3, 4. And I'm going to have a horizontal line going across my y-axis. Now, that's going to be a solid line because I have that line under the sign. So let's go ahead on and graph that solid line, if we will. And then I have to figure out the direction in which I'm going to be throwing my shade. And so in this case here, since it's less than or equal to, that shade is going to be being thrown downward here. All right. And so any point that you can think of that's in the shade is going to be a solution. So for instance, if I have 4, -6, that would be a solution. But conversely, if I had -2, +2 up here, that wouldn't be a solution because it's not in the shade. All right, let's do another example while we're at it. Number 8 is very similar to that. So if that was the hoy, this is the, let me change colors here just to emphasize this. This is the vux. All right, the V standing for vertical, the U undefined, and then the X. X equals or X axis here. So this time I have X is greater than 7. So instead of having a horizontal line like we had before, we're going to have a vertical line since we have the X all by itself on the left-hand side here. So let's go to 7. 1, 2, 3, 4, 5, 6, 7. And I'm on the X-axis because it's an X by itself here. And so then I'm going to be graphing that vertical line here. But it won't be a solid line since it says greater than. It's actually going to be a dashed line here. So let's just go ahead and line this one up, shall we? Dash, 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 and dash. So then we have to figure out what direction am I going to be throwing my shade here. It won't be up and down like we've been doing before here, but since it says greater than, my shade is actually going to be going to the right here, aka any number greater than the 7, okay? So that's the direction in which we're going to be throwing our shade. All right, I'm going to do one final example with you here, and that's number 6 on this sheet that's right here. So once again, I'm going to isolate y by itself. So I'm going to subtract 3x. And then I'll have the 2y less than or equal to -3x. All right, and then in order to get y by itself, my final thing is I have to divide by 2. And so I have y is less than -3x, or -3/2, I should say. All right, so this one's going to be kind of interesting here. So what you'll notice when we're graphing this is something a little bit different. You'll see that there's a slope, and the slope is a number before the x. So we'll have that -3/2. But is there a y-intercept? Well, no, there's no y-intercept. So that, well, actually there is a y-intercept, it's 0. It's just not listed here for you. All right, so we always begin at the b. So if we're going to do that, our very first point is actually going to be at the origin. And then we can go ahead and graph our slope here. So I have a -3, so that's telling me I have to go down. That +2, I'm going to have to go to the right. So we're going to go down 3, 1, 2, 3, and then over 2, 1, 2. And so we'll go down 3, over 2, down 3, over 2. And of course, I have to go in the opposite direction, up 3 over 2, up 3 over 2, and then up 3 over 2. So what's my line going to be? Well, since I have a less than symbol, it's actually going to be dashed here. So we're just going to go ahead and do a dashed line. And then we just have to figure out which way are we going to throw the shade here. And so since that is a less than here, I can just go ahead and throw my shade downward here, okay? And any potential solution would be in the shade. So if I had -2, for instance, that would be a solution because it's in the shade. Conversely, if I had 3, that would not be a solution because it's not in the shade. All right, so that is all for lesson 9 here. Hope to see you guys again for lesson 10. Bye.